How's it going, everybody? I wanted to make a quick tutorial showing how to make Game of Life using JavaScript. It's displaying this on HTML website. As you can see, it looks mostly like this. We're going to be able to change the size, the colors, and be able to change the speed of it all, because it looks a little jumpy right here. But we can quickly look up the Game of Life. The Game of Life is it's a game designed to show how particles interact with one another, and it's a simulation basically. And there's very few rules, but basically you have a 2D grid, at least the basic one is just a 2D grid where the cell is either alive or dead. And you can see some of the rules right here. It says if the cell has fewer than 2 neighbors, neighbors is a cell right beside it, then it is underpopulated and then it dies. If the cell has more than 3 neighbors, it's overpopulated and then it dies. If there's 2 or 3 neighbors around a cell and it's dead, it's going to populate that dead cell and it's become positive, or it's become alive then. So it's a real simple simulation that's able to create a lot of forms of, I guess you can say, life basically. In the recent video, we looked at some simulations as well, and we're going to be doing a simple simulation where you guys can follow along to do this. So you can go ahead and just type in any file you want. I'm just calling it life.html, so it's just going to be an HTML file. We're going to have this HTML tag, and breaking that up, we're going to put in the title, which is going to be called Conway's Game of Life, just like that. And we're having a canvas. The canvas is actually what we're going to be drawing to. So this is really simple, and it should work on anyone's computer, be it Windows, Mac, or Linux. And we're just going to give it an ID. We're going to call it Conway. That way, so once we get into the JavaScript, we can reference this canvas using the ID. And we give it a width and a height. As you can see, this is full screen, but we'll go ahead and change a little bit. So let me save that and reload. And this is what we have right now. There's a blank screen. The canvas is there, but you can't actually see it because there's no color to it. We'll set up a style. In the style, we'll just get the margins and the padding. We'll just set that to 0, so the canvas is filling up from the borders, basically. But of course, you can change this around to be however you like. And now let's do the actual JavaScript right here. In the JavaScript, we're going to want to create an element, an object from the canvas. We just do like this, and we do get context, and that's 2D. And we want to get the width and the height. So this is just getting the width and the height from what we previously had set. And then we want a size of the pixel, basically, because we're going to make the canvas, split it up into a grid of X and Y, and we want it split up by the pixel size, and then this is, we're going to have it as 5. And from here, we're going to have this quick function for drawing a pixel. We give it the X and the Y coordinate, the color, and the size. And it's going to work just like this. You set the style, when you're setting the color, and then you're filling the rectangle at that point, so it's X, Y, and then you're filling it you're making a square, so it's the same width and height. And then we are going to keep track of a grid, which is going to be an array of the X and the Y, and we're also going to have a temp grid, because in the game, you will update to see what's alive and what's not alive, and you'll update on that onto the temporary grid, and then you'll replace the previous grid with the temp one. So we'll have the temp grid just like that. And now we're going to want an init function where we want to initialize basically the grid and the temp grid. And to do that, we'll just call the init function right here. And we have a for loop that will loop through the width and the height. And it's just the width divided by size and the height divided by size. And in here we have a random math function that will just give us a random number from 0 to 1. So 50%, we're going to set it to alive. We also need to initialize the grid and the temp grid so they're the right size. So we'll go ahead and do that. We're also going to be creating an update function, which is called after the init. And in the update, we want to generate, we want to call the update over and over. And this is how you do it. So once it renders the frame, it'll render it again this way. And we're going to set the screen to be black. And we're clearing the screen as well. And here we're going to initialize the arrays as I had mentioned. So it's just a quick 2 for loops for the X and the Y. And we're going to have this temporary array where you create the array and you're able to create an array of the width size, and then you push an array inside of there. And we're just setting everything to 0 or false. And then we can quickly set the grid and the temp grid to in this initialize array, which is the width and the height divided by size, of course. And back in the update function, we will be updating all the individual elements in the grid, and we're just going to loop through that, and we're going to call just this function called update cell. And update cell is going to be a function that's going to look at the cell's neighbors. And like I'd mentioned, we're going to update the temp grid, and then we're going to save that to the actual grid. So in here, we're going to go through and draw the actual grid. We're just checking if the grid is true, and then we're going to draw it. And for now, we're just going to set it to red. So in our update cell function, we're going to want to count the neighbors. We're going to have another function for that. And we basically just want to follow these rules. And so if it's greater than 4 or less than 3, then it's going to set it to 0. If it's equal to 0 or 3, then it's going to be, if its neighbors is equal to 3, and if it's at 0, then it's set to 1. If not, the element or cell is just going to remain the same. We can create a cell value function. That's just to make sure so we can pull a value that is in the cell. This is just to get rid of any error checking, so we don't accidentally look at a cell that's either greater than the width or greater than the height or less than 0. Because for checking the neighbors, we're going to be looking around the cell, so you're going to pass in +1 or -1 where the x and y is. And if we want to see if there's actually a cell on that point, and if we're checking -1, if we're checking width +1, it's going to be outside of the raised bounds, and that's going to give an error. So that's the point of this function right here. And it's as simple as this. Here's these. We're basically just looking at this point, and we want to look at the point above it, point to the left and the right, and the diagonal points as well. So of course this one is x -1, this is x +1, y -1, y +1, and then you can do the same thing for all the diagonals. So that's what we're doing, and we're just counting all of the cell's neighbors. And then in here, we're actually just going to keep track of how many cells were alive at the given moment, and so we're just going to count that. We're just counting which cells are being drawn, basically. And we can actually change the color. We can change that to RGB like this. And we can pass in X and Y as the red and green, and I'll just pass in 100 as the blue. And that'll give a similar color to the one that we looked at from the start. If we pass in this function to set timeout, we can set the timeout to 40, so that way there's a slight delay, so it doesn't render instantly. So it's kind of slow. It looks a little bit nicer this way. And we can also reinitialize it, so we're just calculating the percentage as the width and the height divided by count. So if about 96% of the whole entire screen is dead, we're just going to reinitialize the game. We can also change the width and the height to be the full screen. So right here, let's get the width and get the height, and we're basically just setting the canvas's width and height to the whole entire window's width and height. And that's basically it for how this is going to work. We can comment this out real quick, and we can try running it right here. As you can see, we have our canvas, and it seems to work like we had planned. Let's remove that. That should be full screen now. And the colors, like I mentioned, they're based on just on the X and Y coordinates. You can play around with that to change your colors. You can also play around with the rules. So this right here gets the neighbor count, but you can change the rules right here to generate different things. But this is the way for the game of life right here. As you can see, once 96%, I believe we set, is dead, then we reinitialize the game of life. So yeah, hopefully this was a quick tutorial that makes sense for you guys to follow along. Hopefully this is helpful to somebody out there, and thanks again for watching, and see you guys again next time.